Hi, and welcome to the Module 10. Ready to go on the module quiz. So let's get started. Number one, the two dots, two dot plots shown, they show the number of miles run by 14 students at the start and end of the school year. Okay, compare each measure for the two dot plots and use the data for numbers 1, 2, and 3. So here's a start, miles run. Okay, and then at the end of the school, this is the miles ran. Yeah, it kind of makes sense. You have a full school year, and so this data kind of shifts more to the right. Right, the minimum number here is 5, and now the minimum number is 6, and there's more students running 10 miles at the end. So the means, and here are the means to number 1 for the start, 7.5. So the average number here is 7.5, and for the end here is 8.2, and this is where I got that. The mean for the starts is right here. I'm going to make this a little bit smaller. So we have we take all of the data, and there were 14 numbers, so we divided by 14, and that total was 105 divided by 14, get you 7.5. And then for the end of the school year, all the data points, there are 14 data points at the end, and that total was 115 divided by 14. It's about 8.2. So there you go, 7.5 to the start, and the end is 8.2. Okay, let's look at the next one. Oh, so the medians are the median start is 7.5 and the end is 8. And I can get the medians here. So all that data, once again, you can see here the data, here's 5 and 6, 6 and 5, 6, 6 and so on. So all this data is being added here. But now here's all the data. You have to first take the smallest number and then build them up all the way in order. So you have to rearrange them, right? Because, well, I guess you don't have to rearrange them so much. But anyway, you take the middle number, which is, well, we have 15, oh, we have 14 numbers, So you take the middle two. So 1, 2, 3, 4, 5, 6, 7. So the middle number is right in between. You have to average the two, and that's how you get this here. Whoops. So this is how we get number 2. You take the two middle numbers and divide it by 2. That's 7.5, and so that means the median is 7.5. And for the end of the school year, here's all the data for the end of the school year, rearranged from smallest to biggest. And because there are two middle numbers, we would generally take their average. But since they are both the same, it's equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8 in between. It's both. Yeah, you would do the same kind of thing here, but 8 plus 8 divided by 2 is still 8. And therefore, the start median is 7.5, and the start and the end median is 8. And number 3, our number 3 is the ranges. And we can see this one's pretty easy. The range is the smallest number to the biggest number. So 10 minus 5 is 5, and 10 minus 6 is 4. Next, we have comparing the data. And we have two box plots show the lengths of flights in inches by flown by two model airplanes. Use the data for numbers 4 and 5. So which has the greater median? Well, we can have this median here and that median there, and clearly it's A. So that's A. Oops. Gotta undo that. Okay, sorry. So that's A. And then which has the greater interquartile range? This is another visual thing, because the interquartile range is the left side of the box, the distance from the left side to the right side. So what it's asking, which one has a larger size box here from left to right? And clearly it's B. That from there to there is larger. I mean, you can find the exact value, but we can see it visually. It's airplane B. Now, number 6 is using statistical data to compare populations. And Roberta grows pea plants, some in the shade and some in sun. She picks 8 plants of each type at random and records the heights. Okay, so here's the plants in the shade, plants in the sun. Wow, overall, it looks like the plants in the sun are taller than the ones in the shade. Kind of makes sense. And so express the difference as means of the multiple of their ages. Well, here's the answer, 2.4 times the ranges. And let me show you how to get that answer. For number 6, we have this. So the data, all this data here is presented here. There were 8 numbers. And all this data here, you can see 21, 24, 19, so on. That's all here. So I'm going to bring us over to this. So the means, if you calculate the means, that's the average. So you add them all up and divide by 8. And when you do that, you get 10. And then the mean for the sun plants, you add these up and divide by 8, and that's 22. So we need to know what the range of each of these are. So the range of the shade is, well, we have to look at the biggest number here, which is 12, and the smallest number is 7. So 12 minus 7 is 5. And the range for the sun plants, well, what's the biggest number? It looks like it's 24, and the smallest one is 19. So subtract 24 and 19, and you get 5. So the range is the same for both of these. Now the difference in the means. The mean is for the first one, or for this one, for the sun plants is 22, and for the shade plants is 10. So the difference in the mean is 12, and the difference in the means is how much bigger. So the difference in the means is 12. How many times bigger is it than the ranges? Well, the ranges are both 5, so okay, that's easy. And so really that's a division question, and 12 divided by 5 is 2.4. Okay, and pretty generic question here, but essential, right? How can you use and compare data to solve real-world problems? Here's my generic answer. You can identify similarities and differences in groups. Quite simple. And that's about all you got to know. It's a quick one. Thanks for watching.